We're also going to get some quadratic trig. So we're going to have to review a little bit of how do we solve equations that have quadratics in them. For example, if instead of coses I have x's, could you solve it? So if you just had x's, like x squared minus x, you would solve this with factoring. Right? If I factor out the common factor of x, this helps me because, and the reason we factor is the following. Right now, this is two things that are subtracted that equals 0. Guessing and checking two things that subtract to equal 0 is a lot of options. It could be 3 minus 3. It could be 5 minus 5. How do we know which one it is? But if we factor, what we're doing is we're changing adding and subtracting, in this case, to multiplying. And if you multiply and your answer is 0, anytime you multiply two things and the answer is 0, well, that means this one has to be 0 or this one has to be 0. One of the two numbers has to be 0. If the first one is 0, that tells us that x had to be 0. If the second one is 0, that tells us x has to be 1. This is the reason we factor, to change something that's adding and subtracting to multiplying. And we have to factor when it's equal to 0, because 0 is the only thing that if you multiply, you know that one of the answers has to be 0. Like if I had it equal to 5, well, there's so many things that multiply to equal 5, especially if you get to decimals. So now we do the same thing with trigonometry. You say, I have a cos theta in common. I could factor that out, and that would leave me with cos theta minus 1. And now since I'm multiplying here, either this one is 0, or this one is 0. And if this one is 0, cos theta would have to equal 1. If it's a non-calculator question, you're going to say, are these values on my unit circle? This looks like the axes family to me. When is your x coordinate equal to 0? At pi over 2 and 3 pi over 2. In your axes family, when is your x coordinate equal to 1? Only right here, right at 1 comma 0. So then theta could equal 0 or 2 pi. Now something that's going to come up quite a bit is you're going to have to double check your domain. So in our case, our domain said where 0 is less than or equal to theta is less than or equal to 2 pi. Sometimes the textbook does this. I'm going to show you what the textbook sometimes does. I'm going to do it in red. Notice the slight difference. Not really a lot of difference, but there's a tiny thing that's different. Under the second inequality, there's no equal sign. This would mean that 2 pi is not included. And if you did the same question and you included 2 pi, I would have to take off a half a mark, because in the red one, it's not included. In the green one, it is. So we have to make sure that we look carefully at our domain, because sometimes a value is going to be included and sometimes it's not. Another thing I would say, read the question over again. That's one of the things you want to double check, is your domain. Textbook, if I'm normally doing the question, I tend to more often include them both. The textbook likes to sometimes not include it, so just be careful with that.
This is your.
Mm-hmm.
What if you complete the square?
You could complete the square and then square root both sides with the plus or minus and solve that way. It would work as well.
Same thing.
It will, but this is easy.
Okay.
Okay?
Yeah, okay.
So what's going to happen is when you have trigonometry, you might off the side just think about what would I do if it wasn't, right? What would I do if I had just an x? Okay. In this case, how many of you, would you factor or would you get the x squared by itself? Probably get the x squared by itself. Okay. So then when you go to solve your trig one, sort of follow that same strategy. I'm going to move the 3/4 over to the other side to get the sine squared theta by itself. And then I get rid of a squared by square rooting. Square root both sides. And why would I lose a half a mark? Yes.
Plus or minus.
Plus or minus. Actually, in this one, you'd actually lose a whole mark. I'll tell you why in a bit. Really important in this question, the plus or minus actually loses you a whole full mark by the end. And the reason for that is, well, we need to solve this. First of all, is that number on your pie plate exactly like that? No. But if this is non-calculator, it means it should be. So what do we have to do? We have to use some of our math skills and say, if I have a square root of a fraction, does that make sense that that's the same as the square root of the top divided by the square root of the bottom? And the square root of the bottom is one that I can do mental math, that just becomes a 2. And then it looks like something on our unit circle. What family has root 3/2 for your y coordinate? If we find the family, then we find our reference angle. We know that our family is the pi/3 family. Again, I suggest memorizing one really well. I have sine of pi/6 as a half. So as soon as I see it's not a half, I know it's not pi/6. So then it's probably pi/3. And then for your answers, well, since it's plus or minus, it's all 4 quadrants. And this is why you would lose, each of those answers is worth half a mark. So if you forgot the plus or minus, you would miss 2 of the answers and lose a whole mark in this situation. The one right before?
Why did you cancel?
I said, if it was like this, you would keep the 2 pi. So the answer, the way that it's written, you should have the 2 pi. If the textbook sometimes writes it like this without the equal sign, then you would have to cancel the 2 pi. So we have to be really careful with the domain. A factoring review. In grade 12, the expectation is that you go directly from a trinomial like this to its factored form. You will get easier ones in grade 12 than you did in grade 10. In grade 10, you probably learned a couple of methods for doing this, and you're able to use whichever method you like. But if the method you like, you don't remember how to do it, then it wasn't a very good method for you. Okay? I would suggest that in grade 12, you go directly to the answer and double check that it's right. And there's a couple of things for factoring that work out really nice. First thing in factoring, that whatever you put first, those ones have to match up with the first one. And in this case, with whole numbers, there's only one option. Do you see that the only option is 2 sine theta and sine theta? I mean, technically, writing the sine theta and 2 sine theta, the order when you write the first one does not matter. So there's only one option. If there's only one option, it's not hard math. Okay? The last number, right? The last number will always be what you write. The last 2 have to multiply that last number. This one, extremely easy. There's only one option, 1 and 1. Now, it could be plus 1 and plus 1 or minus 1 and minus 1. We'll talk about the signs next. But as far as the number goes, you know that it has to be 1 and 1. So as far as knowing a method from before, there's nothing we've had to think about yet. Everything has sort of been predetermined. So I'm going to suggest doing this for factoring, because most of grade 12 ones, it's not going to be super hard. And in fact, if it is a little bit hard, just pick a wrong answer and check it. And you'll be amazed how fast you find the right answer. So I always look at my first ones first and look at what option there is. Then I look at my last ones and look at what option. And then finally, I go, okay, to be a plus 1, they're either both plus or both minus. But when I multiply this out, can you see that this and this have to combine to be this? In English, we sometimes use the acronym that these are your outside ones and these are your inside ones. So we spell the word FOIL to help us remember to check everything. But it's just distributing everything and multiplying things out. Can you see that they both have to be minus to get the minus 3? And after I think I figured everything out, I do a quick check. Do my first ones match? Yes. Do my last ones give me plus 1? Yes. Do the outside and the inside give me minus 3? Yes. And then I can say, well, I factored, so now it's multiplying. Either this one is 0 or this one is 0. And by grade 12, if you make this equal to 0, don't write this down. This is what you're thinking in your head. If that's equal to 0, can you see that you could easily move the 1 over and divide by 2 to get that? That would be, you're fine to just write this to this. The purple you can just have in your head. In my head, I know that 2 sine theta minus 1 could equal 0. I move the 1 over, divide by 2. In my head, sine theta minus 1 could equal 0. So if I get sine theta by itself, sine theta would equal 1. Next, we're not done yet. We still haven't solved for theta. Are these values on your pie plate? Yes. What family has sine theta's 1/2? Pi over 6's. And it's positive, so it's going to be in quadrant 1 and quadrant 2. This looks like an axis family. Sine is your y-coordinate. When is your y-coordinate 1? Pi over 2. So you're going to find that the non-calculator ones are quite nice, because you don't have to find your reference angle, think of the cast rule, and solve everything. Oh, next level of question. The next level of question has a sine theta and a cos squared. Okay? Normally this would mean, if you use variables, you're asking yourself, how do I solve, well, maybe I'll make, just because sine is my y-coordinate and cos is an x-coordinate, if I did this, could I solve that? No. We can't solve that because we have 2 variables we don't know, but only 1 equation. In grade 10, you learned about systems of equations where if you had 2 things you don't know, you needed 2 equations. If you had 2 equations, then you could use substitution or elimination to solve. So if you just have this, you're not able to solve it. Okay? They won't give you this on a test or the exam, the hint, but one of our big ideas is always a second equation. So I can't solve this because it has sine theta and cos theta. But I can take the big idea and I can rearrange it. Can you see that it would be easy? Well, I'll show you 2 rearrangements. I could get the cos squared theta all by itself by moving the sine squared theta over to the other side. Or if I wanted, I could get the sine squared theta all by itself by moving the cosquared theta to the other side. This one is going to be helpful because I can substitute where the cosquared is with a sine 1 minus sine squared. And what that will do is it will change my equation. So I'm going to rewrite my equation was minus 3 sine theta minus, and then I'm going to rewrite everything except for the cosquared. And instead of the cosquared theta, I can now substitute in 1 minus sine squared theta, which makes my equation have only one trig function instead of two. I would have to distribute this negative. And if I combine my like terms, do you see, I'm going to write the sine squared first, because for factoring it's nice to have what's squared first. And it's going to be a positive sine squared when I distribute that negative. I'm still going to have minus 3 sine theta. And I have minus 3 minus 1, I'll have minus 4 equals 0. Again, for factoring, if I look at my first one, at sine squared theta, there's only one option, which would be a sine theta and a sine theta. When I look at the 4, I have more than one option. It could be 2 and 2 or 4 and 1. But I need my outside and inside to make 3. So you should pretty soon realize 2 and 2 is not going to work. Because if I do 2 and 2, my outside's 2, my inside's 2, that never makes 3. But if I choose 4 and 1, that could make 3. I need a negative 3. Do you see that negative 4 plus 1 would give me negative 3? That tells me this has to be negative, this has to be positive. Again, once you've factored, multiply it out to double check that it works. This is an interesting question because here I get sine theta equals negative 1, and here I get sine theta equals 4. Can you see that negative 1 is axis family? It's on your unit circle. Can you see that there's never a 4 on your unit circle? So initially, you might think that this side is non-calculator, but this side is calculator. But I'll tell you, this question is all non-calculator. It's non-calculator because this side, okay, y-coordinate of negative 1? Good with 3 pi over 2? But how do you do the left side if it's non-calculator and it's not on your pi plane? Okay. Conversion to what? Well, yeah, but we have to find the angle. So, what angle is it? How do we do this? Oh, like change from radians to degrees? Well, you don't know the angle, so you have nothing to change. The 4 is the ratio, right? If you think about what sine means, sine is the opposite over hypotenuse. So if we draw a nice little right-angled triangle here, right, we would have the opposite side as 4 and the hypotenuse as 1, if I made this a fraction. Does that bother you at all? That's, right? It should bother you a little bit. What's wrong with my triangle? Yeah, now it bothers you, right? Does that, what? Yeah, how can the, is it possible that the hypotenuse is less than the side? No. This is why this is non-calculator. The answer to this side is not possible. Anytime you get a sine theta or a cos theta, if the number is bigger than 1, and you draw the triangle, it's not going to be a possible triangle. So this is why it's not calculator, because they're going to expect you to recognize that. Sometimes it's not possible. And you have to write that it's not possible. If you just leave it blank, the exam marker doesn't know if you know it's not an answer, or if you didn't know and just left it blank. So you have to show that you know that there's no answer by writing not possible or yeah, something there. Okay. Do I have this one on yours, or did I? Yes? Okay. So first of all, in order to factor, we have to make one side equal to 0. If you really don't like to factor, you can always use the quadratic formula. Quadratic formula is going to be on your formula sheet, but it is something that if you're going into AP Calculus, all of your formulas have to be memorized for next year. Quadratic formula is one of them. I'll do a quadratic formula after this one. This one can be factored. Now, the hard part about this one in factoring is I usually start with the first one, but do you see that your first one is tricky? It could be 3 and 2 that makes 6, or 6 and 1. Option 1, you just try one and hope it works, and go from there. If it doesn't work, go to plan B and try the other one, okay? But sometimes you don't have to start with the first one. Sometimes the last one has only one option. You see that the last one has only one option. It has to be 1 and 1. So if you have something that has only one option, and this happens with any prime number, like if the last number was a 5, it would have to be 1 and 5. That would be the only option. If something has only one option, you can start with that. Then the mental math becomes a little bit easier. Okay? If I did the 6 and 1, my outside would be 6, my inside would be 1. Does 6 and 1 ever get you 1, adding or subtracting? No. So that makes me think right away that I should probably use 3 and 2. Does 3 and 2, if I did outside and inside, could it get me 1? Yes, it could get me 1 if the 3 was positive, the outside is positive, the inside is negative. Do a quick check. My first one works, my last one gives me -1. My outside and inside work, so solving for this, I get -1/2, and over here I would get +1/3. This is a calculator question because one part is on your pie plate. So this part you would do without a calculator. Can you see that your reference angle is your pi/6 family? And since it's negative, and you think of your casserole, you're going to be in quadrant 3 and quadrant 4. But the other side, 1/3, is not a y-coordinate on your unit circle. So we find our reference angle by doing sine inverse on our calculator of 1/3. Right, get 0.34. Again, useless in my head. I shouldn't know that. So our reference angle is 0.33. Keeps on going. I would then say, since it's positive, it's in quadrant 1 or quadrant 2. If the question doesn't say what to round to, you go to 3 decimal places. So we would have 0.340, and in quadrant 2, I would go pi minus my reference angle, 2.802. Yes.
Is that when our calculator's supposed to be in radians?
It has to be in radians. Now, this is E. If we would go back to A, prior to A, it said 0 to 2 pi in radians. So if the question gives the domain in radians, you have to give your answer in radians. If the question gives the domain in degrees, you have to give your answer in degrees. So for this one, it is saying that we start with degrees. I'm going to start tomorrow's class by doing one where you have to use the quadratic formula and show you the complexities that. Yeah, the discriminant and yeah, the quadratic formula. So we'll look at how we do that.